All right, so let's try the kind of reverse problem here, which is, hey, same setup. We owe $200 on our credit card that we forgot about, 20% yearly interest, and now we're asking, okay, the collection guy on the phone says, hey, you owe $1,000 on this, and I'm thinking to myself, man, how long has it been since I forgot about that credit card? Right? So we can figure it out. As long as there aren't any late fees. If there are late fees, you're totally host on. Okay, so what am I asking here? What's my formula that's relevant? How'd you guys figure out the first one? Okay, you use this like, okay, your balance is your principal times 1.2 raised to the,
5 years, so your x is the x.
yeah, like some kind of number of years, right? But what's your balance?
Equals 1,000.
Doesn't get ruined by getting a little wet.
Your balance is 1,000 right there. So I think you're operating with this equation. You have 1,000 equals 200 times 1.2 raised to the x power. And now you're having like flashbacks to algebra 2 probably.
Yeah.
So long.
Okay, so when I'm solving an equation with an x in the exponent, what do I do?
Move the 200 first.
Move the 200 first.
Yeah.
Okay, so what you want is plain number to a power, right? So you want to kind of isolate your x's, and in this case that's going to get, all right, I'm going to divide by the 200 here. So that's my first steps first.
So you get 5 equals 1.2x.
Perfect. So I'll get 5 is 1.2 raised to the x. Okay. This thing, right, is what happened to the amount you owed, right? It went up by a factor of 5. You guys see that? That's like balance over principal ratio. Okay, and that's 1.2, right? That's the interest rate kind of raised to the number of years. Okay, so how the hell do I get to x then? Yeah, I gotta do some kind of logging to this. The beauty of this is it doesn't matter which one it is. Yeah, so it doesn't matter what base you pick. I would pick, what's that? What? Say that louder.
Just do LL.
Yeah, just natural log it.
I don't remember log at all. I remember hating them, but I don't remember how to do them.
Okay, cool. So the relevant fact you need to know is that there's a log rule.
Okay.
Okay, and the log rule that we want to use right here is this one. If you log some number to a power, you can take the power outside and multiply by the log of the thing. Cool? So this is the magic log rule that you'll need for this class. There's a good reason for this. We can go through it later if you want. But I'm going to trust that the rest of you all have seen justification for this in algebra 2. Maybe? Okay. You need to know that thing. So what I'm going to do is I'm going to hit both sides of this guy with a natural log. So I'm going to get on the left what? I get the natural log of 5. And on the other side, I'm going to get the natural log of 1.2 raised to the x power. You'll put lots of excess parentheses here. Okay, and then this magic log rule, right, in blue, is going to let me do what?
Move the x in front of the log.
Yeah, take this x, pull it down there. So this step's going to be a log rule, right? That's really the blue log rule that I'm applying there. And I'm going to get log of 5 is x log of 1.2.
And then you can divide both sides by log and 1.2.
Okay, careful.
No?
don't divide both sides by log, because log's a function,
Okay.
right? So you can't unlog everything because you did that on purpose. What you can do is divide by the number log of 1.2. You guys see this? So this thing here is a number. It's a messy number, but it's just a number. So divide both sides by that. So then I'm going to end up with log of 5 divided by what? Log of 1.2. And that's my x. And do not do the dumb thing and cancel the logs.
Oh.
So that would be a little, let me give you an analogy. Canceling the logs would be a little bit like this.
And cancel the x's.
Oh,
Is SI supposed to
Or,
mean something?
you know,
It's the same
the
thing.
number.
It had, like,
Not really.
Okay.
It doesn't mean anything without the x. You guys see that?
Yeah.
That would be like me going, okay, I've got 6 over x, so that's this. I'm going to cancel the x's, and then I get si out of it.
Oh.
Like, I had something that made sense, and then I did some nonsense, bogus, like, symbol canceling, and got something that didn't make sense. So over here, what you have is you're doing the function log to the number 5 on the top, and you're doing the function log to the number 1.2 on the bottom. Those are giving you two different numbers. Those two different numbers ratio is not 5 divided by 1.2. They do not cancel. Cool?
Okay. Cool.
All right. What do you get for them?
A number, what?
Like, here I'm at x is this, right?
Number, like 8.827.
Good question.
8.8.
Okay.
Mine's
We need to talk about calculators for a second. When you try to put this in your calculator, you need to make absolutely sure that you close the parentheses. Because if you write,
Yeah.
so this thing into a calculator should get you x is log parenthesis 5 parenthesis divided log parenthesis 1.2 parenthesis. If you forget this crucial parenthesis here, this one,
Your argument with a natural
Oh,
log.
man.
it will divide the 5 by the log of 1.2 and then take the log of the whole jazz, which is a totally different thing. You guys cool with that?
Yeah.
So just be careful, make sure you're closing parentheses as you go. What do you get out of this? You get x is about
8.83.
8.83.
But if you plug just 8.8 in, you don't get 1,000, you get 99.5.004.
Yeah, the collection gets probably exaggerated. Or it has actually been 8.83 watts. Years. Okay, so I would say it's been 8 years. Wait,
More than that.
8.83 doesn't make any sense in years, right?
8 years and some months.
And days.
Nearly 9 years.
I think maybe that's better. Almost 9 years. We could figure out how many months, right? How would we figure out how many months?
Or multiply.
Yeah, I think you could multiply this whole thing by 12, or you could multiply the 0.83 bit by 12.
Do they compound interest in the middle of the year?
Yeah, credit card companies do, but not in this example. Right, because I said right here, right here,
We decided
pounded yearly.
By year, yes.
So they're compounding at the end of every year. Other credit card companies compound monthly, which is probably more likely. So that will be our next thing. Any questions on this?
You said we were going to watch a video.
I did.
Yeah.